So we're now going to look at matrix powers of matrices which are not diagonal. If you've not watched the previous video on matrix powers for diagonalized matrices, watch that first, and then you can come to this point here. And we're going to use this matrix P in a very clever way to find this matrix A to the power 6. It's not diagonal, so we can't use the result from the previous video. But we are going to use this matrix P. Now you might think, well, where on earth have I got this matrix P from? And that is what the next step will be, which is to find how you get this matrix P using eigenvalues and eigenvectors. But let's not confuse things for now. Let's just have a little look. Now, it's a very clever matrix which is found in a very clever way, but what it does is very cool. Let's have a look at what it does. First of all, we need to find the inverse of P. Okay, which we can do. It's the product here, 3 times 1 minus 1 times negative 1, so that's a quarter, so determinant's 4, sorry, the determinant is 4, so it's 1 over the determinant, and then we switch these positions, don't we, and we take the negative of these two. So there's the inverse of P. And then what we do is we consider this. Now you might be thinking, well, hang on a minute, where did this matrix P come from? That's going to come later. Let's see what happens when we consider this. That's a quarter, 1, negative 1, 1, negative 1, 3. Then we put the matrix A, and I should say I'm considering the matrix A now not as the power. I should have said that, sorry. I'm just going to consider that as matrix A for now. Okay, we're going to ignore that power of 6 for now. I'm just going to look at this matrix as 0, 3, 1, negative 2. And you'll see this very cool thing happen. This we'll come to later, how we find that power of 6. Here we go. So we do a bit of the matrix algebra now, and then that's going to be P. So I'm considering inverse of P multiplied by this matrix A without the power, and then multiplied by matrix P, which is 3, negative 1, 1, 1. Now watch what happens. This is pretty cool. Okay, we'll leave that quarter there for now. Which one should I do first? Let's do this one first. So 1 times 0, 1 times 1, that's 1. 1 times 3, 1 times negative 2, that's 1. Negative 1 times 0, 3 times 1, that's 3. Negative 1 times 3, 3 times negative 2, that's negative, what is that? 9, negative 9, multiplied by 3, negative 1, 1, 1. There we go, that's the first step. Okay, and so then next, let's have a look. It's a quarter, and then we get 1 times 3 is 3, 1 times 1 is 1, that's 4. 1 times negative 1 is negative 1, 1 times 1 is 1, so that's a 0. 3 3s are 9, negative 9 times 1 is negative 9. Whoa, here we go, now the cool stuff's happening. 3 times negative 1 is negative 3. Negative 9 times 1 is 9, negative 12. And we've got something really cool that's happened. Some of you have realized already probably. Hang on a minute, quarter times 4, that's 1, 0, 0, and that's negative 3. What have we managed to do? We've diagonalized our matrix. That is very, 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 very cool, because in the previous video we worked out that we can find powers of diagonal matrices very, very, very easily. So now that is a very cool result. We can call that, let's call it D, the diagonalized version of A. The diagonalized version of A. I looked for a bit of notation how you say this is the diagonalized version of A. It doesn't seem to be one. I thought I'd put in the subscript, but we'll just call it D for now. So what have we got now? We've got this result. Look, let's just highlight these things. This is very cool. We've got this expression, my matrix P, is equal to this diagonalized matrix D. So let's carry on from here and write that down. Let's go this there. So whoopsie-daisy, I've not taken off my my marking up. There we go. Right, now this is cool because we've got this matrix, the inverse matrix of this, the inverse of P, this matrix, which I gave you, times A times P is equal to this diagonalized matrix D. Now, if you know a bit of matrix algebra, we can pre-multiply by inverse of P and post-multiply by matrix inverse of P. So let's do that. Let's pre-multiply by P, both sides, and the inverse of P. We're going to do that both sides, of course. So doing both sides, we get this, don't we? We get P, D, P. That's one on that side. So all I've done is I pre-multiplied. Oops, pre-multiplied by P, see? And I got post-multiplied. I think that's the phrase. Post-multiplied by the inverse, you see? But those other statements are still the same. So that's the same as above, and that's the same as above. So what do we get overall? Well, of course, P times inverse of P, that's identity matrix. That's like 1 in matrix form, A, and then P, inverse of P, that's identity matrix 2, that's 1 as well. So what do we end up with? We end up with this matrix statement now that my matrix A is equal to P, D, P minus 1. Okay, great. How does that help us find? How does that help us find the power of the matrix? Because if you remember at the very beginning, what I did was just completely ignore the power. So at the beginning, I completely ignored that power of A. Let's go back up and I'll just show you that again. Oh no, that's previous. There's our previous result. But here, I completely ignored my power of A. I completely ignored it. Okay, so I want to try and find my result here. So I need to now go back to that matrix and try and find that power and write it down. Well, what have I just found out? I've just found out that if we've got matrix A, just write that down again. What's the original matrix A? Let's go back and have a look. Oops. Let's go back and have a look at that original matrix A. It's 0, 3, 1, negative 2. 0, 3, 1, negative 2. So 0, 3, 1, negative 2. And I've got my diagonalized matrix D as, this is a diagonalized version of A as 1, 0, 0, negative 3, using that very clever matrix P. So you might still be thinking, where did I get that from? Well, we'll find that out next time. I'm going to find that out when we look at eigenvectors and eigenvalues. Well, how does that help me find this power now of A? Well, I want to find A to the power 6. But I know from above that A equals P, D, P inverse. So A to the power 6 is going to be P, D, P inverse to the power 6. Well, if we consider what that would look like, that would look like P, D, P inverse times P, D, P inverse times P, D, P inverse times P, D, P. Obviously, you wouldn't normally do this, but I'm doing it to make a point. 1, 2, 3, 4, 5. P inverse. But of course, we absolutely know. We use this fact above that P inverse. This is all identity matrix. These statements here are all. Oh dear, let me do that again. Let's mark this up properly. We know that inverse of P times P, 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 inverse of P times P. Well, all of that is identity matrix. Each one of those is the identity matrix. So that's identity. This is where you get into the cool parts of mathematics now, where new steps build and build and build, and you get these wonderful results. Okay, so what do we end up with? We end up with P, there's a P, there's a D, but you get D times D times D times D times D times D, that's D to the power 6. And then inverse of P. And look, A to the power 6 is equal to P, D to the power 6 times inverse of P. You might be thinking to me, well, that's not really simplified things that much. But of course it has, because if you watch the previous video, you'll know that powers of diagonalized matrices are very easy to find. And suddenly maths has been made incredibly easy for you because D is a diagonalized matrix. Wow, and that is incredible. So now you've got A, power 6, and all you've got to work out is that thing there. And we know P, let's go back and have a look what P is. P is 3, negative 1, 1, 1. 3, negative 1, 1, 1. Oops, 3, negative 1, 1, 1. 3, negative 1, 1, 1. D is this diagonalized matrix. 1, 0, 0, negative 3, 1, 0, 0, negative 3, to the power 6. And then the inverse of P, we found that right at the beginning, didn't we? Where is it? The inverse of P is a quarter, 1, 1, negative 1, 3. 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 3. Yes, it was. Okay. So now, before we had a horrible situation where we couldn't find A to the power 6 because it was a non-diagonalized matrix. I didn't show you this, but it doesn't follow those same rules from the previous video of powers of diagonalized matrices. But if you just do a simple attempt, you'll see that it doesn't work very well when you try to find powers of non-diagonalized matrices. But here, the power of that diagonalized matrix is incredibly easy to find because we showed in the previous video that it's simply one to the power 6 and negative 3 to the power 6. And that now is a relatively straightforward thing to compute. Okay, a relatively simple thing to compute. So yeah, you should be able to work through that and end up with the power of this matrix A. And what we did was use this very, very clever method just to go back and show you. We started off trying to find a power of a matrix which was not diagonalized, and we couldn't use the previous result about diagonalized matrices. Now the previous result, which you can watch from the other video, is that for a diagonalized matrix, and again, diagonalized square matrix, I should say, this is true. You can watch the other video just to confirm this. That only works for diagonalized square matrices where there's non-zero entries in the diagonal from top left to bottom right and 0 entries everywhere else. That only works in that case. And that's been proved in the previous video. So we went in and tried to find a power of a matrix like this, which is not a diagonalized matrix. And if you try to work this out by hand, you'll be there a long time. You can do it, of course, but it was a bit painful. So I introduced this matrix P, which is directly linked to this matrix. This is a very special matrix. It's not just kind of randomly chosen, it's been calculated. I haven't told you how yet. And we use that matrix P, we find the inverse of it, and then we consider this inverse of P times A times P, where A is the non-powered version of the matrix. And I did that mathematics, we found a pleasing result. That result was that we get a diagonalized matrix from this result. We get a diagonalized matrix. So we get this statement here. And then we use a little bit of matrix algebra, to pre-multiply by P and post-multiply by the inverse of P to achieve this statement. Now, as soon as we got there, we could use some clever maths, because then, of course, if our matrix A is this matrix P times D, we can use powers of the diagonalized matrix to achieve